Let's take a look at problem number 15. Let me get my color changed back. There it goes. And first I'm going to do this by hand, and then I'll show it on the calculator. We got y is greater than or equal to negative 2x plus 3. Now, let me write the steps over here. There we go. This would be graphing a linear inequality in two variables. Step 1, pretend the inequality symbol is an equals and graph like normal, with a stipulation that if you have a greater than or less than, you're going to have a dotted line. If you have a greater than or equal to or less than or equal to, it's going to be a solid line. Let's see if I can actually do that. I just want to underline it. How do I underline? Try that. There we go. Okay. Step 2. Pick a test case and plug it into your original inequality. And then if it's true, then shade the side where the test case falls. If it's false, shade the other side. So let's see what we're talking about here. Okay, so we're going to pretend that we're looking at graphing y is equal to negative 2x plus 3. Well, the plus 3, this is in slope-intercept form. So this would be our y-intercept, 3. And our slope would be the number that's before our x. Slope would be negative 2. But I want to write it in fraction form, so I'll put negative 2 over 1. So this means down, wait a minute, this is change in y over change in x, yeah, down 2, and this means right 1. So from where this point is, I go down 2 and right 1, put my second point. Now this is a greater than or equal to, and remember in our steps, we said greater than or equal to is a solid line. So that means there'll be a solid line here. Now, step 2, pick a test case and plug it in your original inequality. I'm going to pick the origin. That's almost a perfect one to pick, if you know which side it falls on. Obviously, the origin, which is right here, falls on this side of the line. Now, if your line went through the origin, then you wouldn't want to use it, of course. And we'll plug it into our original inequality. Y is greater than or equal to negative 2x plus 3. So put 0 in for the y, 0 in for the x. And this is more of a question mark at this point. We're wondering if that's true. So negative 2 times 0 is 0, and then 0 plus 3 is 3. So the question is 0 greater than or equal to 3? And it's not, so this is false. Now our steps say if it's false, you shade the other side. If it was true, then we'd shade the side where the test case falls, where this point is. But since it's false, we'll shade the other side. So we're going to shade that side. And that'd be our answer. Let's see which one it matches. Okay, we're shading to the right, which looks like C. Dropped my pen. I didn't say a bad word. Okay, there I got it. Okay. Now let's double check that. 15C. Yep. and that checks. Now let's say I was doing this on the calculator. Basically, we're going to graph it, and then if we have a, draw this, if we have a greater than or equal to, we want upper right hand triangle, and if we have a less than or less than or equal to, we want our lower left hand triangle. Now our note that we put over here about the dotted line solid line still holds true, so keep in mind it's a solid line. But let's graph this and see what in the world I mean by these triangles. So press clear, I'll press y equals, press clear, and I'll put in negative 2x plus 3. Now you don't have to have a 0 on y2, that's left over from a previous problem. I'm going to do a left arrow key, clear to the left, and you can't do it too much. We want to put our flashing cursor on this slash in the first position. Now we'll press enter one time, it changes to a thick slash. Change it one more time, and it changes to an upper right hand triangle. Well, if we look at this problem is a greater than or equal to. Greater than or equal to is we want the upper right hand triangle. So that's the one we actually want. Now if we press enter one more time, it'd give us a lower left. And then we press graph. Now a calculator pretty well gives you everything, except for it doesn't tell you if this line separating the shaded region from the non-shaded is a solid or dotted line. And the fact that we have a greater than or equal to in our problem means it's going to be a solid line. So that's how you can get the graph with the calculator. Now you have to have it solved for y, but personally I think if you're doing it by hand or via the calculator, solving for y first is your best option.